Hello, this is Frank Farrisee giving you a quick demo of XGEN's generative search versus conventional keyword indexing search. Here I have two sites pulled up, Valentino US and Dior US, competitors. Valentino US is the one leveraging XGEN generative search. Dior is leveraging conventional search. We're going to give you a quick rundown of the differences between the two and what the results were. Okay, so first of all, we'll start off with something simple. Red dress, easily recognizable by birth. Engines both find red dresses. The issue here is that because red is indexed on Dior, it's also pulling up red plates, several red plates, in fact, that do not actually match what we're looking for. Okay, as you can see on Valentino, it's done an excellent job of curating perfect items for the customer. Okay, what about black dress? Okay, Valentino finds it perfectly well. So does Dior, in fact. But let's change this query to something a little bit more exciting. What about dark, a variation of black? Well, something interesting is happening here. Dark is not indexed in the product feed, does not exist in their product feed. Same with Dior. But look what happens on keyword search when I search for dark dress. The results crash. What's happening here? Well, XGEN's generative models can speak the English language, and in fact, 120 languages. So what they do is they translate the question back to something that can be found in a combination of the images and the textual data coming from the product feed very rapidly. This can be extrapolated out to pretty much anything in regards to colors. How about the term Gothic? Not a color, but a vibe that spells something similar. Going even deeper, even the concept vampire dress. It can still find what we're looking for. Again, vampire and Gothic, nothing to do with Valentino, still finds it exceptionally well. Okay, the next example here is quite interesting. I'm going to go ahead and go back to red dress, and I'm going to ask for a variation of red. So in this case, ruby. Similar, but not identical, okay? Ruby could equate to red, but it's also a slightly more shiny red. Ruby is also not indexed in Valentino's feed, yet it does find it very well. Okay, another example that I want to iterate here is natural language, multi-language capabilities. I can type in red dress in English, I'm in the US product feed, and I can find it. What happens if I change one of those words to Italian, let's say, rosso dress? So in this case, the search engine GenSearch is translating the term red or rosso back to red so that the search engine can find it very quickly. In fact, we can do this with the entire language. So if I type in red dress in Italian, rosso vestito, it still finds it perfectly well. If I test this on Dior, it says, sorry, there's no search results found. Again, you don't index Italian language in the English feed. That's the problem. Okay, moving on to another example here. We're going to ask a question that's a bit broader, okay? So what about a question that does not contain a product category? For instance, gold and shiny. These are both descriptions, but they don't necessarily indicate a specific product. Well, the response here is nothing exists in the feed that matches what I'm looking for. However, it's going to use the image data to pull back that information using generative enrichment of the general English language to say, what does look gold and shiny in my perspective? And this is exactly what it finds. Another example here is jewelry. So if I type in earrings, oops, of course, the engine finds it. Pretty easy to find. But what if I dial this down a bit more? Casual look. This is where it gets fascinating. If I change this to elegant, it understands the difference between casual and elegant in the product I'm looking for. And again, Valentino does not have elegant and casual indexed or enriched. This is happening in real time to find what the customer is looking for. I can also dial this down to a specific color, making it even more precise in silver, metal color, anything that matches what we're looking for. And again, it finds elegant earrings in silver. Okay, another example here with generative search, which is quite powerful, is I can actually ask much longer natural language questions. Hi, I'm looking for a really nice pair of boots. There's a bit more of a sentence, and again, it does find boots. And the fascinating thing about this is, again, we can dial this in. So, elegant. Interesting. It can find exactly what we're looking for. I actually spelled elegant wrong there. Go ahead and correct that. There we go. Elegant boots, right? Perfect example of what I'm looking for. Yes, XGen powers the faceting, the filtering, the sorting, the ranking. It powers all of it. But the difference with XGen's generative search models is I can now ask directly in the question itself. Another example of this is the concept of asking for a product price within the search query itself, as opposed to using layered ranking in the options over here, faceting. So in this case, I'm going to actually ask for a necklace under 500. 500 does not explicitly state price, but because of the generative pipeline that XGen built onto its recommendation and search engine, it can actually understand in real time that I'm talking about the price in a natural language way. Same thing if I put over, it can find it immediately, necklaces over that price point very well. Okay, the other concept with generative search is, again, it's not necessarily using keyword indexing. It does use it as a part of it, so it leverages the data in the product feed. But let's ask a question that has absolutely nothing to do with Valentino. How about bright Miami vibe? This is a very interesting question because not a single word that I mentioned in this question or query actually exists in the product feed or any of the metadata that Valentino is sending XGen. So this is where the generative nature really takes over. It can actually answer any question you ask it by translating it back to the best possible match in the product feed. In contrast to this, let's take a look at this, dark London vibe. So again, very subjective, much broader question, no exact linking to those keywords in the product feed, but again, it still finds what we're looking for very, very well. And the final thing I'll look at here is as follows. Let's do something fun and even wild. And you can look at this even when generating category pages, not just search. How about I want to look like Barbie? Again, nothing to do with Valentino, no capsule or collection with the word Barbie, doesn't exist in the product feed. But the generated models, again, have a much broader context. They understand some pop culture references, they understand the entire English language as a general subject, and can find the best possible match that we're looking for. So what happened in this use case? Well, ultimately, what happened is when Valentino first deployed this, they weren't prompting their users to use broader questions like, I want to look like Barbie or bright Miami vibe. They were just trying to address the common keywords that were coming into their sites and make them better. So when first deploying XGen AI over their current search engine, their actual click-through rate went up by over 60% and their attributed revenue by over 20%, when deploying just generative to the existing UI without any changes, specifically prompting users to look generatively. But this is the beauty of generative search. Let's take a look at the experience now. As you can see, the customer is now pushing users to shop much more generatively. Lace up combat boots, glitter heels for a holiday party, black and gold evening outfit, luxury sneakers for casual chic. These are, again, very, very hyper-precise questions that can either power a category or directly in search. So with the use of generative search, we're really accelerating the tech stack in the global search for e-commerce to reflect much more natural language and ultimately take 1/10 of the time that it takes to both set up and operate than conventional e-commerce keyword indexing. Thank you very much.